All right, in today's lesson, what we're going to be talking about is section 5-1, linear equations and functions. Before we get into that, we have to do some review of setting up a graph, being able to recognize the parts of a graph. So, looks like a standard number line. And what we're going to end up doing is we're going to use this number line, but we're going to use it a little bit differently than what we've used it for in the past. Going off of this number line, we're going to create another number line. Now this should look familiar, because now what we have is we have a coordinate plane. Going across the bottom, or our horizontal axis, we have our x-axis. So this is our horizontal axis. Going vertically, we have our y-axis. So if we're going up or down, we're going vertical. We're going on the y-axis. Left or right, horizontal, we're going on the x-axis. Now, we think about this just like a number line. Say this is our 0. What we're going to do is we're going to call this our origin. So our origin is at the point 0, 0. It's at 0 on both the y-axis and the x-axis. Up in our top right, we're going to call this quadrant 1. This is where most of things are located. Most of the graphs that you see in business are located in the positive and positive side. What I mean by that is this. On a number line, these are all positive values of x. So we can put that as a positive value here. And going vertically, these are also our positive values of y. Now moving over to the left side here, this is our quadrant 2. So we're going counterclockwise, setting up our quadrants. Now, on a number line, this is 0. To the left of 0 are going to be negative values. And we're still going up on our y-axis. These are all positive values. So in quadrant 2, your x will be negative, your y will be positive. Next up, we have quadrant 3, down on the bottom left. So we're going to start at 0, and moving to the left, we still have a negative. And moving down on the y-axis now, we also have a negative. Finally, we have quadrant 4. So we're going to start at the 0. We're ending up going to the right. So it'll be a positive value for my x. Moving down, it'll be a negative value for my y. I'll step aside so you can get a little bit better look at this, but this is what you should have for your quadrants and coordinate plane. All right. So now that we have this set up for our quadrants and our coordinate plane, it's now time to use it. What we're going to do, first of all, is we're going to set up how to plot a point. So as an example, I could say the point A is -3, positive 5. So -3, positive 5. Graphing coordinate points are always x, y. So we'll start with our x-axis, the number line going left and right or horizontal, and we'll end up with our y-axis, the number line going vertically, up or down. So -3, 5. I'll start at my origin always. And the -3 tells me that I need to move left 3 spaces on the number line. So I'll start at -3. The +5 tells me that I need to go vertically, or I need to go up 5. So I'll go up 1, 2, 3, 4, 5. And we are always going to plot our points with an X. Here's the reason why. I know exactly where the middle of this point is. I don't know where the middle of this point is. So using a circle or using a dot is very, what we call arbitrary, which means that it doesn't have a definite answer. So no dots. We're going to use X's to plot our points. So this is point A. Just as another example, let's plot 4, negative 2. So, starting with my X, I'll begin at my origin and move 1, 2, 3, 4 places to the right. My negative 2 tells me that I need to move down on the Y-axis to 2 below 0. And this is my point B. So just as an example of how to graph, we're going to spend a little bit more time graphing, but this is something that needs to be understood, needs to be done before we really move on. All right. So what we can do is we can use graphs to represent a lot of information. And being able to set up a graph is a very important thing to do. Say we have an example of this linear function. A linear function means that it's going to create a line if I draw it on a graph. Linear line. So this is a linear function, and a problem that you may see is something like this. Is 3, 9 a point on the graph? Now we can do this the hard way. We can graph it all out. We can check to see and see if 3, 9 is on the linear equation that we've come up with, or I can also take these values and plug them in. Recently I told you that all points are x, y, which means that the value of 3 is my x, the value for y is my 9. So I can take these values for x and y and plug them in for y and x. So in this problem, the 9 replaces the value for the y, the 3 replaces the value for the x, and now I need to see, is this point on the line? Well, let's find out. 4 times 3 gives me 12. 12 minus 3 is 9, which tells me that the point 3, 9 is on this line because it makes this true. Makes it true because we get the same answer on the left and the right hand side of the equal sign. Changing this example just a little bit, we want to find out if 1, negative 3 is also on the same exact line. So, I've got my x and I've got my y. Everywhere I see an x, I'll replace it with 1. Everywhere I see a y, I'll replace it with negative 3. Okay. And from here, I'll solve. 4 times 1 is 4. And 4 minus 3 is 1. Now, negative 3 equals 1. Not true. So, the answer for this problem would be no. 1, negative 3 is not on the line because it does not hold true at the end of this problem. A little bit of a helpful hint for you. The next thing that we're going to talk about is standard form. And this is something that you should be able to keep in your notes. We are going to go over this, so it is very important that you have it. That way we can discuss it when it comes time to that part of the lesson. Standard form is written like this. AX plus by equals c. So I've got the x, then my y, then my c. Something very important to know as well, a, b, and c are always going to be constants or coefficients in the problem. Now, it might be that a is a 1 or a negative 1, but it's still a constant, still a coefficient. Make sure that you are aware of this. So, standard form of a linear equation is ax plus by equals c, where a, b, and c are all constants or coefficients. All right? So I'll give you a chance to write that down, then we'll move on. The last thing that we're going to do is graphing using a t-chart. So you've used the t-chart to add and subtract, but now we're going to use it to actually do some graphing. Say I wanted to graph this function here, y equals 2x plus 1. First thing that I'll do is set up a t-chart. My x will be on the left, so this is my input. The right is going to be the output. That's going to be my answer. So that will end up being the value of y. Well, in order to get y in this problem, I need to take 2x and add 1 to it. Okay. So what we do is we take a few numbers, usually small numbers, that can fit our problem, plug them in, and find our answers. So in this problem, I've got -2, -1, 0, 1, and 2 that I'm going to plug in. In order to make a straight line, we need to make sure that we have 3 different possible points that we can plot. So I plug in -2. 2 times -2 is -4. -4 plus 1 is -3. Plugging in -1, 2 times -1 is -2, plus 1 gives me -1. Anything times 0 is 0, 0 plus 1 is 1. And I'll speed this up just a little bit. So I have an input and an output table. What I need to be able to do with these is create some points that I can use on a graph. Well, these are my x values. For each one of those problems. My y values will be my answers. So in this one, my point is -2, comma -3. -1, comma -1. 0, 1, 1, 3, and 2, 5. So I have these 5 points. Now what I'm going to do is I'm going to plot them and see what happens. So I've got my x and my y axis. My 0 is my origin. That's where I'm starting every time when I'm counting for these plotting of the points. So starting at my origin for the first one, keep in mind the values are here. You should have these written down. So now I'm just going to use these to be able to graph. So first problem was, or first point is -2, comma -3. I'll start at the 0, move 2 to the left. Then on the y-axis, I'll move down 3, making sure that I put an x where I want to plot my point. Next up, I've got -1, comma -1. left 1, down 1. Next up, I have 0, 1. So 0 means that I'm not moving anywhere, and I'm going up 1. Next up, I have 1, 3. So I'll move right 1 and up 3. And finally, I have 2, 5. So I'll move right 2 and up 5. These aren't going to be perfect because we don't have graph paper to represent everything. However, it should be fairly close to being accurate. From this point, you should see that it forms a fairly solid positive line. And this is our equation this is our graph for the equation y equals 2x plus 1. Now, the last thing that we'll do is talk about positive slope, negative slope, zero slope, and undefined slope. So, this is a positive slope. The reason for it, we read a book from left to right. We're going to do the same thing with a graph. Moving from left to right, this is a positive slope. It is going up. In comparison, moving from left to right, this line is moving down. This is a negative slope. Also in comparison, if we have our x and our y-axis here, and I draw a line nice and flat like this, this doesn't have a slope. It's nice and flat. There's no difficulty in grade. There's no difficulty in slope. We call this a zero slope. We'll get more into this when we get into slope. However, it is important to know that a nice horizontal line is going to have a zero slope. Finally, we have our x and our y-axis. Say we have a vertical line like this. We don't know how far down this line goes. This is going to end up being an undefined slope. It doesn't move over at all. It doesn't move forward or backward, positive or negative. So we don't know if this is going to be a positive or negative slope. We set this up as an undefined slope. So a lot of content, a lot of information. I want you to take this all in. Make sure you fill out the form that goes with it. Email me with any questions, jstevens1@psusd.us. And we'll talk about it in class. Good luck.